Picture this. You're standing on the shore of an endless ocean, but instead of water stretching to the horizon, it's space infinite, mysterious, and utterly mind-blowing. Now imagine someone tells you this vast cosmic ocean we call the universe might just be a single bubble floating in something even bigger. What lies beyond the edges of everything we know? Could there be other universes with entirely different laws of physics? Or is our reality just a shadow of some higher dimensional truth? Today, we're diving into 25 of the most incredible theories scientists have proposed about what might exist beyond our universe. From parallel worlds to cosmic holograms, from simulated realities to universes inside black holes, each idea is more astonishing than the last. And here's the wild part: some of these theories aren't just science fiction. They're serious scientific possibilities that could reshape everything we think we know about existence itself. So hold onto your curiosity, because we're about to take a journey to the very edge of reality and maybe even peek beyond it. The answers might just bend your mind in ways you never thought possible. Now let's step into the first mind-bending possibility, the multiverse theory. Imagine our universe isn't the only one. Instead, it's just one page in an infinite cosmic library where every possible version of reality exists somewhere. This isn't just wild speculation, it's grounded in real science. Quantum mechanics suggests that particles can exist in multiple states at once until observed. Think of Schrödinger's famous cat, both alive and dead in a box until you look inside. Now stretch that idea to the entire universe. Every decision, every chance event could spawn a new reality, parallel worlds where history played out differently, where you made different choices, even where the laws of physics aren't the same. But it gets even stranger. Inflationary cosmology, the idea that our universe expanded faster than light in its earliest moments, hints that this rapid stretching might still be happening elsewhere, creating bubble universes endlessly. Picture a boiling pot of water with bubbles constantly forming and drifting apart. Each bubble could be a separate universe with its own unique physics. Some might have stronger gravity, others might lack stars entirely. The multiverse isn't a single idea, it's a collection of theories all pointing to one astonishing conclusion. Our cosmic home might be shockingly ordinary in a sea of infinite possibilities. So next time you gaze at the night sky, remember, you might be looking at just one window in an endless cosmic skyscraper. Now let's peel back another layer of cosmic mystery, the brain theory. Picture our universe not as a solitary bubble, but as a slice in a cosmic loaf of bread. This idea springs from string theory, which suggests that everything around us, particles, forces, even space itself, might be made of tiny vibrating strings. But here's where it gets wild. These strings could exist in higher dimensions beyond the three we experience, and our entire universe might be stuck to a vast floppy membrane, or brain, floating in this multidimensional space. Imagine two of these brains drifting through the higher dimensions like sheets in the wind. If they collide, the energy could trigger a cataclysmic event, a big bang birthing a new universe. This isn't just sci-fi. Physicists like Paul Steinhardt and Neil Turok have explored how such collisions might explain the explosive start of our cosmos without a traditional singularity. Even stranger, those extra dimensions could be hiding entire universes right next to ours, separated by a gap we can't perceive, like ants crawling on a table, unaware of the world beneath it. And here's the kicker: gravity, unlike other forces, might not be confined to our brain. It could leak into higher dimensions, explaining why it's so weak compared to electromagnetism or nuclear forces. So next time you drop your phone, blame it on gravity slipping into a hidden dimension. The brain theory isn't just about where we are. It's a gateway to rethinking reality itself, where the fabric of space is richer and weirder than we ever imagined. Now let's take a step into one of the most mind-bending ideas in modern physics, the holographic universe theory. Imagine peeling a sticker off a surface and realizing the image isn't just stuck to it but somehow embedded within the surface itself. That's the core of this theory. Our vivid, three-dimensional reality might actually be a projection from a two-dimensional boundary, like a cosmic hologram. This isn't just wild speculation. It comes from the study of black holes, where physicists like Leonard Susskind and Gerard T. Hooft made a startling discovery. When matter falls into a black hole, all its information, every detail about it, doesn't vanish. Instead, it gets encoded on the black hole's event horizon, the point of no return, like a scrambled message etched onto a vast spherical surface. That realization led to a radical question. Could our entire universe work the same way? Think of it like this. A hologram stores a 3D image on a 2D film, and when you shine light through it, the full picture emerges. Similarly, the universe might encode everything: galaxies, stars, even you, on some distant flat boundary we can't perceive. The 3D world we experience could be a kind of illusion, a projection of that hidden data. The implications are staggering. If reality is just information painted on a cosmic canvas, it challenges our deepest assumptions about space, time, and even free will. Are we just pixels in some grand cosmic code? Could the laws of physics simply be the rules of that encoding? The holographic principle doesn't just blur the line between science and philosophy, it smashes it entirely, leaving us to wonder whether the universe is far stranger and far simpler than we ever imagined. Now, let's turn our attention to a theory that makes the universe feel like a cosmic phoenix, rising, falling, and rising again in an endless loop. This is the cyclic model, the idea that our universe isn't just a one-time event but part of an infinite cycle of expansion and collapse. Picture a balloon inflating to its limit, then deflating, only to inflate once more, except here, the balloon is all of reality. At the heart of this idea is Roger Penrose's conformal cyclic cosmology, a twist on the classic Big Bang and Big Crunch scenario. Penrose suggests that when our universe reaches its end, a state of near-infinite expansion where matter and energy are stretched impossibly thin, it doesn't just fizzle out. Instead, it resets. The cosmos smooths itself into a blank slate, losing all sense of scale, and another Big Bang ignites, birthing a fresh universe. What's mind-blowing is that these cycles, which Penrose calls eons, might leave faint fingerprints behind. Here's where it gets even more intriguing. Penrose and his collaborators claim to have found evidence of these past universes in the cosmic microwave background radiation, the afterglow of the Big Bang. They point to mysterious, ring-like patterns in this radiation, which they argue could be the gravitational echoes of black holes colliding in a previous eon. If true, it would mean our universe isn't just carrying relics from its own birth but ghosts from a cosmos long gone. The cyclic model doesn't just challenge our idea of time as a straight line, it turns it into a spiral. No single beginning, no final end, just an eternal rhythm of creation and destruction. It raises profound questions. Could the laws of physics change with each cycle? Might our universe inherit quirks from its predecessors? And if every eon leaves a trace, how many came before us? For now, these questions linger at the edge of science, where cosmology meets poetry, and where the universe might just be rewriting its own story over and over again. But what if our universe isn't just cycling? What if it's all a meticulously crafted simulation? This brings us to one of the most provocative theories on the table, the simulation hypothesis, the idea that everything we perceive as reality might be an artificial construct, like an ultra-advanced video game. Imagine waking up one day to discover you're not a flesh and blood being but a line of code in some unfathomable computer program. Mind-bending, right? At the core of this theory is philosopher Nick Bostrom's famous trilemma, which lays out three possibilities. 1. Nearly all civilizations at our level of technological advancement go extinct before they can create simulations. 2. If they do survive, they lose interest in building hyper-realistic simulations of their ancestors. Or 3. The spine-tingling option. We're almost certainly living in a simulation right now. Why? Because if even a fraction of advanced civilizations run ancestor simulations, the number of simulated beings would vastly outnumber real ones, making the odds staggeringly high that we're among the digital crowd. Tech mogul Elon Musk has thrown his weight behind this idea, arguing that the rapid progress of virtual reality and video games makes it plausible that an advanced civilization could create a simulation indistinguishable from reality. And if that's true, who's to say it hasn't already happened? But the simulation hypothesis isn't just a sci-fi thought experiment. It raises unsettling ethical questions. If we're in a simulation, would our creators intervene in our lives like programmers tweaking a game? Could disasters or miracles just be patches or updates? And if we ever discovered we were in a simulation, could we hack it, rewriting the rules of physics or even escaping into the real world? Some scientists have even proposed ways to test this theory, like searching for glitches in the fabric of reality, tiny errors in the laws of physics that might reveal the underlying code. Others argue that if the simulation is flawless, we'd never know the difference. So here's the ultimate question. If you couldn't prove whether this was base reality or a simulation, would it even matter? Or does the mere possibility change how you see existence itself? Next, we'll explore a cosmic paradox that flips this idea on its head. What if the universe isn't a simulation but a self-aware mind floating in the void? Stay tuned for the eerie concept of the Boltzmann brain. Now, let's flip the script on black holes, because if they're the universe's ultimate vacuum cleaners, then white holes are their mysterious cosmic fire hoses. Picture this: while a black hole sucks in everything, even light, never to escape, a white hole does the exact opposite. It's a theoretical region of space where matter and energy only burst outward, impossible to enter. Think of it like a one-way door, except instead of pulling you in, it violently spits you out. Einstein's theory of general relativity actually allows for white holes to exist, mathematically speaking. They're like the mirror image of black holes, born from the same equations but with a bizarre twist. Some scientists speculate that if a black hole collapses into a singularity in our universe, it might pop out as a white hole in another, a cosmic tunnel connecting realities. That means every black hole could, in theory, be a secret backdoor to another universe. But here's where it gets wild. White holes might explain some of the most energetic explosions in the cosmos, like gamma-ray bursts. These are sudden, blinding flashes of light so powerful they outshine entire galaxies for a moment. Could they be white holes briefly opening up, ejecting matter from some distant dimension? Even dark energy, the mysterious force accelerating the universe's expansion, has been loosely tied to this idea. What if it's the faint gravitational echo of white holes in other universes pushing against ours? Of course, no one's ever observed a white hole directly, and many physicists argue they're just mathematical curiosities, too unstable to exist in nature. But if they're real, they'd rewrite not just our understanding of space-time, but the very architecture of the multiverse. So next time you hear about a black hole, ask yourself, what's on the other side? A white hole, another universe, or just a tantalizing cosmic mirage? Up next, we're diving into a theory that's even more unsettling. What if the fabric of space itself is a runaway cosmic inflator, endlessly birthing new universes? Hold tight for the mind-bending world of eternal inflation. Now, let's stretch our imaginations even further, because what if the Big Bang wasn't a one-time event, but just the first spark in an endless cosmic fireworks show? Welcome to the mind-bending world of eternal inflation, where the universe isn't just expanding, it's multiplying. Imagine a loaf of rising bread, but instead of yeast, it's fueled by an invisible energy that never runs out. As the dough expands, bubbles form inside it, each one a self-contained universe with its own unique physics. Some might have stronger gravity, others might have faster light, endless variations spawning forever. This idea comes from Alan Guth, the physicist who first proposed cosmic inflation, the theory that our universe underwent a crazy fast expansion right after the Big Bang. But here's the twist: inflation might not have stopped everywhere. In some regions, it could keep going eternally, birthing new pocket universes like bubbles in a boiling pot. String theory takes it even further, suggesting these universes could exist in a vast landscape of possibilities, each with different fundamental constants. Some might be barren, others might teem with life. Ours just happens to have the right recipe for us. But how does this actually work? Think of space as an infinite stretch of fabric with tiny quantum fluctuations tugging at it. Wherever the fabric stretches enough, a new universe pinches off, carrying its own rules. It's like a cosmic assembly line churning out realities non-stop. And here's the wild part: we might never see these other universes because the space between them inflates faster than light can cross it. They're forever out of reach, hidden beyond the horizon of our observable cosmos. So, is eternal inflation science or speculation? While it's hard to test directly, some theories suggest clues might hide in the cosmic microwave background, the afterglow of the Big Bang. If we spot strange patterns there, it could hint at collisions with other bubble universes. Until then, it remains one of the most thrilling and humbling ideas in cosmology. Because if it's true, our universe isn't special. It's just one bubble in an endless, frothy ocean of reality. And speaking of reality bending ideas, get ready for something even stranger. What if the universe isn't just expanding, but could randomly conjure up a fully formed, conscious brain out of nowhere? Stay tuned for the eerie paradox of the Boltzmann brain. But let's take a step into the truly bizarre, because what if everything you know, everything you are, isn't the result of billions of years of evolution, but just a fleeting accident in an endless sea of nothingness? That's the spine-chilling premise of the Boltzmann Brain Paradox. Picture this: in the vast, empty stretches of space, over incomprehensible stretches of time, random particles could suddenly arrange themselves into a fully functioning, self-aware brain. No body, no universe around it, just a lone, conscious mind popping into existence, complete with false memories of a life it never lived. This nightmare fuel comes straight from the laws of thermodynamics, specifically the idea that entropy, the universe's tendency toward disorder, can sometimes reverse locally. Given enough time, even the most improbable events become inevitable. So, statistically speaking, a fully formed brain materializing out of chaos is more likely than an entire universe like ours evolving naturally. Think about that for a second. If randomness can conjure up a single observer, how do we know we're not just Boltzmann brains, hallucinating reality for a split second before dissolving back into the void? Physicists have wrestled with this paradox for over a century, ever since Ludwig Boltzmann linked entropy to the arrow of time. The grim conclusion: if the universe truly lasts forever, Boltzmann brains should outnumber real, evolved beings like us by an unimaginable margin. So why does our universe feel so stable and ordered? Some argue that if we were Boltzmann brains, our perceptions would be nonsensical, just fleeting noise. The fact that we see consistent laws of physics might be evidence that we're not cosmic glitches. Others propose that the universe has a built-in expiration date, preventing infinite time for these freak accidents to dominate. But here's the real kicker. The Boltzmann Brain Paradox forces us to confront how little we understand about consciousness, reality, and our place in the cosmos. Are we the improbable winners of a cosmic lottery, or just statistical anomalies in an indifferent void? It's a question that blurs the line between philosophy and physics, and one that might never have a satisfying answer. Now let's shift gears from lonely, disembodied brains to something even more elusive, a ghostly parallel universe made of dark matter lurking right beside our own. Stay tuned for the phantom universe hypothesis. But if the Boltzmann brain left you questioning reality, brace yourself, because the phantom universe theory takes the mystery to another level. Imagine a ghostly twin of our cosmos, made entirely of dark matter or dark energy, existing right alongside everything we know but completely invisible to us. It's not science fiction, it's a real possibility physicists are exploring. Here's how it works. Dark matter, that elusive substance making up most of the universe's mass, doesn't interact with light or ordinary matter the way atoms do. Its presence is only felt through gravity, tugging on galaxies and bending space itself. But what if that gravity isn't just from unseen particles? What if it's the fingerprint of an entire parallel universe overlapping ours like a shadow? Some theories suggest dark matter could be made of particles from this phantom realm, drifting through ours unnoticed. Others take it even further, proposing that dark energy, the mysterious force accelerating the universe's expansion, might actually be the gravitational pull of this hidden cosmos leaking into ours. Picture two sheets of paper pressed together. Even though they don't mix, their presence affects each other. Scientists are hunting for clues. Experiments like the Large Hadron Collider are searching for exotic particles that could bridge our universe with this hypothetical twin. Meanwhile, telescopes map dark matter's gravitational effects, looking for patterns that might betray its otherworldly origins. If they find evidence, it could mean we're living in a cosmic double exposure, two universes sharing the same space but forever out of reach. The implications are staggering. A phantom universe might explain why dark matter behaves so differently from everything else we know. It could even rewrite our understanding of reality itself, suggesting that what we see is just one layer of a far more complex cosmic tapestry. So the next time you look up at the night sky, remember, there might be an entire unseen universe staring back. Now, let's turn to an idea that flips cosmology on its head. What if our universe isn't expanding into empty space, but instead we're inside a black hole? That's next with Black Hole Cosmology. But before we dive into the mind-bending idea that we might be living inside a black hole, let's take a step back and ask, what if our entire universe is just the interior of something much bigger? Here's where Black Hole Cosmology comes in. Picture this: every black hole in our universe could contain an entirely new cosmos within it, and our own universe might just be one of those nested inside a black hole from a parent universe. It sounds like science fiction, but some physicists argue it could solve one of the biggest mysteries in cosmology: the singularity at the heart of black holes. Normally, singularities are points of infinite density where physics breaks down. But if the inside of a black hole expands into a full-fledged universe like ours, then the singularity is no longer a dead end. Instead, it's the birthplace of another reality. This idea ties into the holographic principle, which suggests that all the information in a three-dimensional space could be encoded on a two-dimensional surface, like the event horizon of a black hole. In other words, our universe might be a projection of data stored at its boundary. Lee Smolin took this idea even further with his fecund universes theory, proposing that black holes are cosmic reproduction centers. Every time a black hole forms, it spawns a new universe inside it with slightly tweaked physical laws. Over countless generations, universes that produce more black holes, more offspring, would dominate, meaning our universe's laws might be fine-tuned for black hole production. Think about it. If this is true, then the cosmos could be an unimaginably vast family tree of universes, each born from a black hole in another. So the next time you gaze at the night sky, remember, you might not just be looking out into space. You might be peering into the depths of a black hole's shadow, a gateway to something far grander. Now, let's unravel another twist in the cosmic puzzle. What if time itself is looping back on us? That's up next with the time loop universe. Here's a fresh way to think about time. What if the universe doesn't just move forward but actually loops back on itself? Imagine a cosmic reset button where the end of everything isn't an ending at all, it's the start of another beginning. This is the core idea behind the time loop universe theory. At first glance, time seems to move in one direction. Eggs break but don't unbreak, memories form but don't unform. That's the arrow of time, driven by entropy, the universe's tendency toward disorder. But what if, when entropy reaches its maximum, the universe doesn't just fizzle out? What if it bounces back, resetting all the chaos into a new Big Bang? Some physicists suggest quantum effects could make this possible, bending the rules we think we understand. This idea isn't entirely new. Philosopher Friedrich Nietzsche toyed with a similar concept called the eternal return. The notion that everything that happens has happened before and will happen again in an endless cycle. While Nietzsche's version was more metaphorical, modern cosmology takes it literally. Could the universe be stuck in an infinite replay, with each iteration slightly different due to quantum randomness? If true, this changes how we see existence. There'd be no true beginning or end, just an endless loop of creation, destruction, and rebirth. Every star, every galaxy, even you and me, might be part of a cycle that's repeated countless times before. And if quantum fluctuations tweak each cycle, who's to say the next version of the universe won't be entirely different? Now, let's shift gears to another radical idea. What if reality isn't made of matter, but of pure mathematics? That's where the mathematical universe theory comes in. Now, let's take a step into something even more abstract. What if the universe isn't just described by math, but actually is math? That's the bold claim behind the mathematical universe theory, proposed by physicist Max Tegmark. Imagine peeling back the layers of reality until all you're left with isn't matter or energy, but numbers, equations, and pure structure. Tegmark's idea flips the script on how we think about existence. Instead of math being a tool humans invented to explain the cosmos, he suggests math is the cosmos. Think of it like this: our universe isn't just running on mathematical rules, it is those rules. Every particle, every force, even the fabric of space-time could be nothing more than an abstract mathematical object playing out its predetermined role. This leads to a wild implication. If reality is purely mathematical, then every possible mathematical structure must exist somewhere. Our universe, just one entry in an infinite library of mathematical realities. Somewhere out there, there could be a universe where 2 + 2 = 5, or where gravity behaves in ways we can't even fathom. The kicker, these alternate realities wouldn't just be hypothetical. They'd be as real as ours, just with different equations governing them. Critics argue this pushes science into metaphysics. How could we ever test a theory where literally everything is possible? But Tegmark counters that the elegance and universality of math make it the simplest, most fundamental layer of reality. After all, why wouldn't the universe be mathematical at its core? From the spirals of galaxies to the orbits of electrons, math consistently describes the patterns we see. Maybe that's not a coincidence, maybe it's the cosmic blueprint. So, if this theory holds, the answer to what lies beyond our universe might not be more universes but more math. A vast, unchanging realm of abstract truths where our physical world is just one flickering equation in an eternal sea of possibilities. Next up, we'll explore a far more unsettling idea. What if our universe is sitting on borrowed time, teetering on the edge of annihilation? That's the vacuum decay catastrophe. But before we dive into the unsettling possibility of a cosmic reset, let's talk about a danger lurking in the very fabric of reality itself. Picture the universe as a fragile glass perched on the edge of a table. One tiny nudge and everything shatters. That's the vacuum decay catastrophe in a nutshell. Here's the chilling idea. Our universe might not be in its most stable state. Right now, we exist in what physicists call a false vacuum, a temporary, high-energy arrangement that could, at any moment, collapse into a true vacuum. Think of it like a valley surrounded by mountains. We're sitting comfortably in that valley, but there's a deeper valley below us, one with less energy. If quantum fluctuations ever push us over the edge, we'd plummet into that lower state, rewriting the laws of physics in an instant. What happens next is the stuff of cosmic horror. A bubble of this true vacuum could form anywhere in space, triggered by a random quantum event. Once it appears, it would expand at the speed of light, obliterating everything in its path. Atoms, forces, even the structure of space-time, all of it would be replaced by new rules we can't predict. The worst part, we wouldn't see it coming until it was already here. Light from the edge of this bubble couldn't outrun the destruction, so there'd be no warning, no time to react. One moment, reality as we know it exists, the next, it's gone. Some scientists argue this could have already happened elsewhere in the cosmos, with those regions forever cut off from us by the expanding wall of doom. Others point out that the fact we're still here suggests our vacuum might be more stable than we fear, but the terrifying truth is we don't know for sure. The universe could be a ticking time bomb and the timers hidden from view. So, if vacuum decay is real, what lies beyond our universe might not be alternate dimensions or parallel worlds, but an abyss of nothingness waiting to rewrite existence itself. Now, let's lighten the mood, sort of, with a theory that flips the script on matter itself. What if there's a mirror version of our universe where everything runs backward? That's next. Now, let's take a step into the looking glass with a theory so bizarre it feels like science fiction, except it's rooted in real physics. Imagine a universe almost identical to ours, but with one crucial twist: everything is flipped. Matter becomes antimatter, left becomes right, and time itself flows backward. This is the mirror universe, a cosmic doppelganger predicted by something called CPT symmetry. Here's how it works. CPT stands for charge, parity, and time, three fundamental symmetries in physics. Charge means swapping particles with their antiparticles. Parity is like looking in a mirror, flipping left and right. And time reversal is exactly what it sounds like, running the clock backward. According to CPT symmetry, if you apply all three transformations to our universe, you'd get a valid, physically possible reality. A mirror universe where antimatter dominates, molecules twist the opposite way, and cause happens after effect. But why should we believe such a thing exists? For one, it could solve a cosmic mystery, the missing antimatter. In the Big Bang, matter and antimatter should have been created in equal amounts, annihilating each other instantly. Yet somehow, our universe is stuffed with matter, and antimatter is vanishingly rare. A mirror universe could be the answer. What if antimatter didn't vanish, but escaped into its own flipped reality? Now here's where it gets mind-bending. If this mirror cosmos exists, would its inhabitants experience time the way we do, or would their lives unfold like a movie in rewind? Entropy, the measure of disorder, always increases in our universe, giving time its arrow. But in a CPT-reversed world, entropy might decrease, making the future look like our past. Imagine mirror beings who remember tomorrow and forget yesterday, watching stars not explode but reassemble, of course, proving any of this is a nightmare. A mirror universe would be almost impossible to detect, since any signal it sends would have to traverse a barrier of reversed time and flipped physics. But the idea isn't just wild speculation, it's a serious hypothesis that could explain some of the universe's biggest puzzles. So the next time you glance in a mirror, ask yourself, is it just reflecting you, or a doorway to a world where everything is inside out? Up next, we'll explore an even stranger idea, one where every decision you make spawns an entirely new universe. Welcome to the many worlds interpretation. Hold onto your hats, because we're diving into one of the most jaw-dropping ideas in quantum physics, the many worlds interpretation. Picture this: every time you make a decision, no matter how small, the universe doesn't just follow one path. Instead, it splits into multiple realities, each one playing out a different outcome. That's the wild premise proposed by physicist Hugh Everett in the 1950s. Unlike the multiverse theories we've explored, where universes exist independently, the many worlds interpretation suggests we're constantly branching into alternate versions of ourselves right here, right now. To grasp this, let's revisit Schrödinger's cat, that famous thought experiment where a cat in a box is both alive and dead until someone checks. In the many worlds view, there's no single outcome. Instead, the universe splits. In one world, the cat is alive; in another, it's dead. Both realities exist simultaneously, just on separate branches of an infinite cosmic tree. Every quantum event, from an atom's decay to your choice of breakfast, triggers a new fork in the road, spawning universes where every possibility becomes real. Now, how does this differ from other multiverse ideas? Bubble universes or brain collisions happen far beyond our reach, but many worlds suggest alternate realities are unfolding all around us, invisible yet intertwined. There's no need for parallel worlds to be physically distant; they're layered right here, separated only by quantum probabilities. And here's the kicker: if this is true, there's a version of you who became an astronaut, another who moved to Bali, and countless others living every imaginable life. But wait, how could we ever prove something like this? The eerie answer is we might not. Since these branches don't interact, there's no way to peek into your alternate selves' lives. Critics argue this makes many worlds untestable, more metaphysics than science. Yet supporters counter that it's the simplest explanation for quantum weirdness, ditching the need for particles to collapse into a single state. Why choose one outcome when the math allows for all of them? So here's a thought to chew on. If every possibility plays out somewhere, does that make our choices meaningless or infinitely more profound? Whether you're team many worlds or not, one thing's certain: it's a theory that turns reality into a choose-your-own adventure book with endless endings. Up next, we'll zoom into a radically different cosmic cycle, one where universes aren't born from big bangs, but from colossal collisions in higher dimensions. The ekpyrotic model awaits. Now, let's turn to a cosmic cycle that flips the script entirely: the ekpyrotic universe. Forget a single explosive Big Bang. Imagine instead that our universe was born from a monumental collision between two higher dimensional membranes, or brains, floating in a vast, unseen dimension. This bold idea, rooted in string theory, suggests that the birth of our cosmos wasn't a one-time event but part of an endless loop of creation and destruction. Here's how it works. Picture two enormous sheets floating in space, vibrating like drumheads. When they slam together, the energy of that impact ignites a new universe, our universe. Unlike the traditional Big Bang model, which starts with a mysterious singularity, this collision avoids that infinite density problem entirely. The ekpyrotic model smooths out the wrinkles, offering a cleaner origin story where the universe emerges hot and dense, but not infinitely so. But wait, there's more. This theory also tackles one of cosmology's biggest puzzles: why the universe looks so uniform. The standard explanation, cosmic inflation, proposes a fleeting moment of rapid expansion to iron out irregularities. The ekpyrotic model, though, suggests those smooth conditions were baked in from the start. As the brains slowly approach each other over eons, their energy stretches and flattens space naturally, no inflation required. Of course, this raises questions. If universes keep recycling through these collisions, could traces of past cycles linger in ours? Some theorists speculate that gravitational waves or subtle patterns in the cosmic microwave background might hold clues. Others argue that without observable proof, the ekpyrotic universe remains an elegant but unverified hypothesis. Yet whether it's the ultimate answer or just a fascinating detour, this theory reminds us that the cosmos might be far stranger and more rhythmic than we ever imagined. Next up, we'll explore an even more mind-bending idea. What if every universe is just a single pixel in a vast holographic multiverse? Now, let's take things a step further into the realm of the truly mind-bending, the holographic multiverse. Imagine if every universe in existence isn't just a separate bubble or a floating brain, but a tiny piece of a much larger cosmic puzzle. Picture our entire cosmos as a single pixel in an incomprehensibly vast multidimensional image. That's the core idea here. Reality itself might be an intricate hologram where every universe is encoded as information on a grand cosmic scale. This theory blends two radical concepts, holography and the multiverse, into something even stranger. Remember how the holographic principle suggests our three-dimensional universe could be a projection from a two-dimensional surface. Now, stretch that idea across countless universes. Instead of just one hologram, think of an entire multiverse where every universe is a fragment of a deeper, higher-dimensional code. Information theory tells us that everything, space, time, even matter, might boil down to bits of data. Entropy, the measure of disorder, could be the glue that holds this cosmic code together, determining how reality is structured and how information flows between universes. But what does this actually mean? If the holographic multiverse is real, then the laws of physics we think are fundamental might just be emergent properties of this underlying information network. Quantum entanglement, for example, where particles instantly influence each other across vast distances, could be a side effect of how data is shared between these cosmic pixels. Even the arrow of time, why we remember the past but not the future, might trace back to how entropy organizes information in this grand scheme. Of course, the big question is, could we ever prove it? Some physicists speculate that subtle irregularities in the cosmic microwave background or unexpected patterns in black hole radiation might hint at this deeper layer of reality. Others argue it's more like a philosophical framework, a way to unify physics rather than a testable hypothesis. But whether it's the ultimate truth or just a stepping stone, the holographic multiverse pushes us to think differently about existence itself. Next, we'll venture into an idea that blurs the line between science and speculation. What if the entire universe operates like a giant neural network, with space and time as interconnected nodes in a cosmic brain? Now let's shift gears to something even more unexpected. What if the universe itself is thinking? Picture this. The cosmos might not just be a vast expanse of stars and galaxies, but a sprawling, self-organizing neural network, almost like a cosmic brain. This isn't science fiction, it's a cutting-edge theory gaining traction among physicists and philosophers alike. Here's the wild idea. Space and time could be made up of interconnected nodes, firing and wiring together the way neurons do in our brains. Instead of empty vacuum, imagine the fabric of reality as a web of dynamic connections, constantly processing information. Some researchers suggest that the universe might not just contain consciousness, it could be conscious in some fundamental way. This ties into panpsychism, the view that consciousness isn't just a human trait but a basic feature of reality, like mass or energy. The parallels between cosmic structures and neural networks are eerie. Galaxy clusters, with their filaments and nodes, resemble the wiring of a brain on a colossal scale. Even more intriguing, quantum computing hints at how information might flow through these cosmic synapses. In quantum systems, particles can exist in multiple states at once, processing vast amounts of data in parallel, just like a neural net optimizing its connections. Could the universe be learning as it evolves, refining its own laws over billions of years? Of course, this raises big questions. If the universe is a neural network, what's it thinking about? Is the emergence of life and our own awareness just a small part of some grand cosmic computation? While this theory is still speculative, it challenges us to rethink what reality truly is. Maybe the universe isn't just a machine, it's a mind. Next up, we'll explore a controversial idea that turns mainstream cosmology on its head. What if electromagnetism, not gravity, is the invisible force shaping the cosmos from the shadows? Shifting our cosmic lens, let's dive into a theory that flips everything we think we know about the universe on its head. What if gravity isn't the dominant force shaping the cosmos? Instead, imagine a universe sculpted by something far more invisible yet powerful: electromagnetism. This is the bold claim of the plasma universe theory, a radical alternative to mainstream cosmology. Here's the core idea: the universe isn't just held together by gravity's pull, but is buzzing with electric currents and magnetic fields. Picture vast, thread-like structures of plasma, superheated, charged gas stretching across space, weaving galaxies together like beads on a cosmic necklace. These plasma filaments, observed in lab experiments and even in distant galaxy clusters, might be the hidden scaffolding of the cosmos. The implications are staggering. If electromagnetism plays a bigger role than we thought, it could explain mysteries like galaxy formation without relying solely on dark matter. Some researchers point to the way plasma naturally twists into spirals and filaments, eerily mirroring the shapes of galaxies and galaxy clusters. Even more intriguing, these currents might connect to larger, unseen structures, hinting at a universe far more electrically alive than we've imagined. But here's the twist: this theory clashes head-on with standard models. Mainstream cosmology leans heavily on gravity and dark matter to explain cosmic structures, while plasma universe proponents argue we're overlooking the electrified elephant in the room. Could decades of physics be missing a fundamental piece of the puzzle? Of course, this idea isn't without controversy. Critics argue that while plasma physics explains local phenomena, it can't replace gravity's role on cosmic scales. Yet the theory forces us to question assumptions. What if the universe isn't just a dark, silent expanse, but a dynamic, electric tapestry? Up next, we'll revisit an old idea with a modern twist. What if the universe isn't expanding at all, but forever balanced in a delicate cosmic dance? Now, let's take a step back, way back, to an idea that once ruled cosmology before the Big Bang theory took center stage. Picture a universe that doesn't expand, doesn't collapse, but simply is, unchanging and eternal. This was Einstein's original vision, the steady-state model, a static universe where matter quietly appears out of nowhere to keep the cosmic scales balanced. At first glance, it sounds almost poetic, a universe that avoids the drama of a fiery beginning or a crushing end. But here's where it gets interesting. Modern astronomers might have dismissed this idea decades ago, but some researchers are giving it a second look with surprising twists. What if redshift, the phenomenon we use to measure cosmic expansion, isn't about galaxies racing away from us? Could it instead be a sign of light losing energy over vast distances, or even interacting with mysterious particles along the way? Proponents of this revived static universe suggest that continuous matter creation, though it sounds wild, might not be so far-fetched. Quantum physics already shows us particles popping in and out of existence in empty space. Could this process happen on a cosmic scale, gently filling the universe with just enough new matter to keep its density constant? Of course, the elephant in the room is the cosmic microwave background, that afterglow of the Big Bang. Static universe models struggle to explain it, but some theorists propose alternative origins, like starlight absorbed and re-emitted by cosmic dust over eons. It's a long shot, but it keeps the debate alive. What's at stake here isn't just a choice between models, it's a question of how we interpret the cosmos. Does the universe evolve, or is it forever caught in a timeless equilibrium? The steady-state idea reminds us that even discarded theories can spark new ways of thinking. Next up, we'll push the boundaries even further. What if reality isn't made of particles at all, but pure information? Now, let's shift gears to something even more mind-bending. What if everything we see, touch, and experience isn't made of particles or energy, but of pure information? This is the core idea behind the information universe theory. Imagine reality as a cosmic computer where every star, every atom, even your thoughts, are just bits in a vast quantum calculation. At the heart of this idea is physicist John Wheeler's famous phrase, "it from bit." Instead of matter being the foundation of the universe, information comes first. Think of it like a video game. What you see on screen isn't real in the traditional sense. It's just code being processed. In the same way, our universe might be the output of a deeper informational layer, with particles and forces acting like pixels in an unfathomably complex program. This perspective flips causality on its head. In a classical universe, events have clear causes and effects. But if reality is information-based, things like quantum entanglement, where particles instantly influence each other across vast distances, start to make more sense. It's not magic, it's more like two lines of code in a program that are inherently linked, no matter how far apart they seem. The implications are staggering. If the universe is a quantum computer, then black holes might be cosmic hard drives storing unimaginable amounts of data. The laws of physics could simply be the algorithms this system runs on. Some scientists even speculate that phenomena like dark energy could be glitches or unused processing power in this grand computation. But here's the big question: who or what is running the program? Is it an advanced civilization, a natural process we don't yet understand, or something even stranger? The information universe theory doesn't answer that, but it gives us a whole new lens to explore reality. Next, we'll venture into an even more mysterious idea. What if consciousness itself plays a role in shaping the cosmos? Let's take this one step further. What if the universe isn't just aware of us, but in some way requires our awareness to exist? This is the heart of the conscious universe theory, an idea that blurs the line between observer and reality. At its core is the anthropic principle, which suggests that the universe's laws appear fine-tuned for life because, well, we're here to observe them. It's like walking into a room perfectly set for your birthday party. You might wonder, is this just luck, or was it designed for me? The strong version of this principle takes it further, proposing that only universes capable of producing conscious observers can truly exist. Forget random chance. Our presence might be the reason reality looks the way it does. Then there's physicist John Wheeler's participatory universe concept. He argued that consciousness doesn't just observe quantum events but actively shapes them. Picture the famous double-slit experiment where particles behave as waves until measured, then choose a definite state. Wheeler wondered, could this mean reality remains fuzzy until consciousness forces it to make a decision? It's as if the universe waits for a mind to look before settling on what's real. This leads to wild questions. Is the moon there when no one's looking? Does the Big Bang trace back to an observer in some deeper reality? While these ideas push the limits of science, they challenge us to rethink our role in the cosmos. Maybe we're not just passengers in the universe, we might be participants, even co-creators. Up next, we'll zoom out to see if the cosmos mirrors itself in infinite patterns, the fractal universe. Now, let's shift our gaze to a theory that finds beauty in repetition. The fractal universe. Imagine zooming into a snowflake and seeing the same intricate patterns at every level, from the tiniest ice crystal to the entire flake. That's what fractal cosmology suggests about our cosmos. Structures repeat themselves endlessly, from the smallest quantum foam to the vast web of galaxies. The idea draws from mathematician Benoit Mandelbrot's work, who showed how nature loves self-similarity. Trees branch like rivers, lungs mimic trees, and now some scientists propose the universe does the same. Look at a computer simulation of galaxy clusters, and you might mistake it for a neural network in the human brain. The filaments of galaxies mirror the synapses of our minds, hinting at a cosmic blueprint where everything echoes everything else. Could this mean the universe is built like a Russian nesting doll, with smaller versions of itself tucked inside? Some models even suggest that black holes might birth new universes, each with its own black holes, creating an infinite fractal cascade of realities. It's a dizzying thought. Our universe might just be one layer in an endless cosmic onion. But here's the twist: if the cosmos truly is fractal, there's no biggest or smallest scale. The patterns loop forever, leaving us to wonder, are we the universe observing itself, or just a tiny ripple in an infinite fractal ocean? Up next, we'll confront a theory that strips it all away, the null universe where nothing lies beyond. Now, let's take a step into the quietest corner of cosmic speculation, the null universe. After exploring theories brimming with multiverses, brains, and holograms, this idea stands out precisely because it offers nothing at all. No hidden dimensions, no parallel realities, just the vast, empty expanse beyond our universe, if there even is a beyond. This might sound bleak, but there's a certain elegance to it. Occam's razor, the principle that the simplest explanation is often the best, cuts through the complexity of other theories. Why invent countless unseen universes when one might be enough? If our cosmos is all there is, then the mysteries within it become even more profound. The void isn't just emptiness, it's a mirror forcing us to confront the limits of our imagination. Yet nothing is a slippery concept. Try to picture absolute nothingness, no space, no time, not even darkness. It's like trying to imagine a color that doesn't exist. Some philosophers argue that the human mind simply can't grasp true nothingness because even the act of thinking about it creates something. So, is the null universe the ultimate reality, or just a trick of our cognition? This theory doesn't dazzle with cosmic fireworks, but it challenges us in a unique way. If there's truly nothing beyond, then every galaxy, every atom becomes impossibly precious. Our universe isn't a footnote in a grander story, it's the only story. And that might be the most humbling idea of all. Next, we'll tie everything together with the ultimate ensemble, where every possible reality exists at once. Now, as we weave together the threads of cosmic possibility, we arrive at the grandest tapestry of all, the ultimate ensemble. Imagine a library so vast that every book ever written, and every book that could be written, sits on its shelves. That's the essence of Max Tegmark's Level 4 multiverse, where every mathematically possible structure isn't just a theory, it's a reality. This isn't just about parallel universes with slightly different versions of you, or bubbles of space-time with alternate physics. Here, every equation that can exist describes its own universe. Circles with 5 sides, universes where time runs in loops, realities made entirely of abstract patterns. If math allows it, it's out there. The ultimate ensemble doesn't pick favorites, it doesn't need to. In this cosmic democracy, every possibility gets its turn on stage. But here's the twist: if everything exists, does anything truly matter? Some argue this idea stretches science into metaphysics, becoming untestable by definition. How could we ever prove or disprove a reality where all proofs and disproofs also exist? Yet Tegmark counters that math itself is the test. If a structure is logically consistent, it belongs in the ensemble. No experiments needed, just pure, cold logic. This theory doesn't just challenge our place in the cosmos, it redefines what cosmos even means. Are we just one scribble in an infinite notebook of equations, or is math the fundamental fabric of existence with universes as its emergent patterns? Whether you see it as the final answer or a philosophical leap, one thing's certain: the ultimate ensemble makes our universe feel both insignificant and astonishingly rare. After all, in a multiverse where anything can happen, the fact that we're here to ponder it might just be the most remarkable coincidence of all. And with that, we've journeyed through the mind-bending landscape of what might lie beyond our universe, from the infinite bubbles of the multiverse to the holographic edges of reality, from the chilling possibility of a simulation to the cosmic cycles of birth and rebirth. Each theory we've explored doesn't just stretch our imagination, It challenges the very foundations of science and philosophy, asking us to rethink what's possible. Some ideas feel like science fiction, while others brush against the edges of equations we're only beginning to understand. Yet all of them share one thrilling truth: the universe is far stranger, far grander than we ever dared to dream. Whether it's the infinite reflections of the many worlds interpretation or the eerie silence of the null universe, these theories remind us that the cosmos still holds mysteries we've only begun to unravel. So here's the real question: which of these wild possibilities speaks to you? Do you find yourself drawn to the elegance of the mathematical universe, or does the chaos of eternal inflation feel more compelling? Drop your thoughts in the comments below. We'd love to hear which theory sparks your curiosity. And if you've enjoyed this cosmic deep dive, don't forget to hit that subscribe button and ring the notification bell. There are always more mysteries to explore, and we'll be here to guide you through every one of them. Until next time, keep looking up, the universe is waiting.